Yeah, hello guys, welcome. This is Learn West Africa. In our series of videos that we will be taking you through the additional maths past questions that has appeared from the year 2015 to the current session. In this series, we'll be looking at permutation and combination. I believe that you are enjoying the videos that we've been showing you, and you are sharing with your friends, and you're also dropping your comments and joining our revision courses and etc. I congratulate you on all the wonderful things that you guys keep putting yourself through. Now, in this session of permutation and combination, we'll be learning about what permutation is, what combination is. If these questions pop up in the exam, what are the things that you need to look out for? The aspect that has got to do with conditional permutations, conditional combination. What do you do when you have those situations? So join me as we go through this set of problems. And again, make sure that you keep on subscribing to Learn West Africa. Share with your friends, drop your comments, and you can also contact us on our website at learnwestafrica.com. So let's go, permutation and combination. May, June 2015, question 5, QP12. A security code is to be chosen using 6 of the following: the letters A, B, C, the numbers 2, 3, and 5, and the symbols, asterisk, and the dollar. None of the above may be used more than once. Find the number of different security codes that may be chosen. If I, there are no restrictions. II, the security code starts with a letter and finishes with a symbol. III, the two symbols are next to each other in the security code. Okay, so for question 5, QP12, under permutation and combination, very interesting problem that was just shown to you on the screen. Now let's just look at the key parts. It says that a security code is to be chosen using 6 of the following: the letters A, B, and C, the numbers 2, 3, and 5, the symbols asterisks, and the dollar sign. And the question says that none of them is supposed to be repeated. And like we've always said, and again I repeat, you can watch the revision course on permutation and combination and just try and bring back to mind all of the points that we are saying. Many times in the problem for your IGCSE, when we say that the letters or whatever objects that are given cannot be used more than once, what we try to mean is that repetitions are not allowed. Okay? So if repetitions are not allowed, then like you would have a situation where the numbers that will come after the multiplication sign will always be reducing. Okay, you will see that in a bit of a short time. So we want to find the number of different security codes that may be chosen. Now let's look at the I part. The I part mentions that in the problem said that there are no restrictions. There are no restrictions. There are no restrictions. So like we said, let's try and construct our box. You would put the boxes for the number of objects that you have to arrange. So we want to create a security code that is made up of 6. We want to use 6 of the objects that are given, the letters, all that, to create a security code. 6, which means that our box will have 6 spaces. Okay, so 1, 2, 3, 4, 5, and let's put 6 there. Hope you are fine with that. Okay, so now we are saying that the letters are A, B, and C. The numbers are 2, 3, and 5. Then the symbols are asterisks and that. So what do we do? Okay, so just notice something here. Now we are saying the letters are A, B, and C. So let's have the letters. The letters is A, B, and C. That gives you 3. So these are the ones that we have. And the numbers are 2, 3, and 5. Okay, that gives you 6 different objects. Then we have the symbols, which is asterisks and the dollar sign. That also gives you 2. So in all, you've got 8 objects. And we are saying that out of the 8 objects, we are going to use 6 of them in trying to construct this particular code. So what happens? We go into our first box. That means that if it is without repetition, then all of the 8 can go in there. Hope you are fine. So you can have all of the 8. If one of them is chosen, that's going to give you 7. Okay? Then you're going to have 8 times 7, then times 6, times 5, 4, and 3. Hope you're okay. All right, so a security code to be chosen using 6 of the following. What happens? So that is what we do. We're going to use 8, 7, 6, 5, 4, and 3. So just do the multiplication of that, and you should have your answer for the number of arrangements that you will get without restrictions. So remember, all of these things will come with multiplication because of the multiplication rule that you give you for the I part. The number of arrangements that are possible for the codes without restrictions is going to be 8 times 7 times 6 times 5 times 4 times 3. I'm sure you can use your calculator to check that out to get your answer. Yes. Then the II says that the security code should start with a letter and finish with a symbol. It should start with a letter and finish with a symbol. All right, so again, we go back and construct our spaces. Now, guys, listen. Anytime you have a permutation question in the exam, look, 9 out of 10 of the cases, you're always going to have a conditional permutation in there, okay? And remember, you can go to our revision course and see how to work with, how to deal with conditional permutation. You can have a conditional permutation there. And I've already explained to you in the revision course and also in the regular course how to deal with conditional permutations or conditional arrangements, whether they are either permutations or combination. All right, so let's try and again create our 6 spaces. Then we'll just look at how we can apply the ideas that we know already on conditional permutations into trying to see how we can solve this problem. So we're going to have our 6, so 1, 2, okay? All right, then we have 3, 4, 5, then we have 6. Okay, so these are the spaces that we have here. Now, let's look at the problem. The problem tells us that the II part says that the security code starts with a letter and finishes with a symbol. It starts with a letter and finishes with a symbol. In conditional permutation, like we already said, the idea is this. The part that the restriction or the condition applies, that is where you need to deal with this arrangement first before you go to the other aspects. I repeat, if a condition or restriction has been given, ask yourself that which part of the box does that condition or restriction affect? Is that clear? So the part of the box, the part of the shape where that condition or restriction will affect, go to that box, go to that space, and deal with that arrangement. Afterwards, you can complete the rest of the boxes. Good. So we are saying that it starts with a letter, finishes with a symbol. That's where the restrictions are. So our restriction is always on the start and the finish. So we don't just go and begin writing our numbers. We have to go and deal with those particular points first. Our start. So let's come here. It says that it should start with a letter. So how many letters have we got? 3. So how many ways can we fill this part? Obviously, you're going to have 3 ways. It's 3 ways because it could either be A, B, or C. That is the only way you can have the first box having a letter. It's either you put an A, a B, or C there. So this is going to give you 3. Then we come to the end, because that is where the other restriction says. The restriction says that it should end in a symbol. So we come here to the end. How many symbols have we got? We've got 2 symbols, the asterisk and the $sign, which means that we only have 2 options or 2 ways as to how we can arrange the end part. So this part is going to give us 2. Okay, so we can do the first part in 3 ways, the first box in 3 ways. Then the latter box will also be done in 2 ways. Guys, hope you're fine. All right, so now that we are done with that, we can now go ahead and complete it. So let's assume that out of the 8, we select 1 to fit there. This part is completed, the other part is completed. What happens? This side is going to give you 7. Okay, so there is 8, and we've taken 2 out. So we are going to have 6. Let me just correct that. Okay, we're going to have 6. Then this part is going to give you 5. Then you have 4. Then you have 3. Hope you're making sense. Okay, so if you're able to do that, this kind of gives you like 6 factorial, right? Because 6 times 5 times 4 times 3 times 2, that's 6 factorial. And this side is going to be 3. So we're going to have 3 times 6 factorial. And that should give you your answer for that. Hope you're okay. Okay. Now, there is something that usually gets students confused. Now, this is the point. Some say that, all right, here we put 3 here. We have got 2 there. How come we are putting 6? Because if there are 8 and you put 3 and 2, that's like 5. So why do you have 6? But now, guys, listen. This box can take 1 letter at a time. What we put there does not represent the letters that is going there all at a go. No. It represents the number of options. So that's the point you need to get about permutation in these kind of problems. So we have the conditional permutation. We put in the boxes the options that are available to us. It doesn't actually mean that in real terms, all those letters will go there at the same time. Obviously, that's not possible. The options are available to you. So in your first box, if you have to start with a letter, how many options are available? 3. If the last part should end in a symbol, how many options are available? 2. After you filled those first and second, how many letters or objects will now be available for the next set? That will be 6. Then you keep on doing that. So get it. What we put in the boxes are the options available to us, but not exactly like the letters or objects that you have there. Okay, so you have 3 times 6 factorial, and that should give you your answer nicely. Okay. Now let's go to, so this, if you work this out, you get that for your I. That's going to give you your II. Let's look at the III. Now, the III says that, for our problem, says that the 2 symbols are next to each other in the security code. That's it. How many arrangements are possible? If these 2 symbols, the asterisk and the $sign, are next to each other in the code. All right, so what do? We'll create our 6 code, our 6 spaces. And remember, we are creating 6 spaces because our code, we are being told, should be a 6. It should be a 6 object code. Okay, so you should have a 6 object code, a 6 spaced code. So you create 6 spaces for that. Let's see. Let's take that again. So that is space 1, space 2, space 3, space 4, space 5. Guys, hope you are fine. All right. So now let's do that. Let's look at the arrangements. We are saying that the 2 symbols should be next to each other. What happens? Okay. So if our 2 symbols should be next to each other, what do? It means that it's either our symbols could come here, they could go there, they could occupy this part, they could occupy this part, they could occupy this part, or they could also go there. Hope you are fine. So the 2 codes could either begin 1, 2, 3, 4, 5, 6. Hope you are done with that. We are clear. So either it goes at the beginning, in the middle, there, 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 there. Or it could also go here. Hope you are fine. Are we clear? So we are looking at that. If we have the 6-digit code there, the spaces that the 2 symbols could occupy, what happens? So this is how we analyze it. It could either fit there, 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 there. So when you look at it this way, what it therefore tells us that how many ways do we have, or how many ways can we place the two symbols? 1, 2, 3, 4, 5, 6, 7. 7 ways. Okay, so 7 ways, we put 7 there. Those are 7 ways. Times. The times means like end, like we said in our explanations. Okay. Now let's look at it. What happens then? Okay. What happens then? So there are 7 ways in which the 2 symbols could fit. Then this arrangement could also be done in 6 different ways, and that's going to give you 6 factorial ways. Remember, we said that factorial means that, like when you take the 2 symbols out, the remaining 6 could be arranged in any way at all. That's what we mean. Okay, the remaining 6 could go in any way at all. And that is what gives birth to the 6 factorial. So it's either the A comes, B comes, C, or 2, or 3, or 5, or whatever. Take the 2 symbols out, you've got 6. So you have 6 factorial. But the 2 symbols can occupy in 7 different ways. But now we come to the last part. The symbol itself. There could be 2 possible arrangements for the symbols. Either the asterisk comes first, then the dollar sign comes second, or the dollar sign comes first, then the asterisk also comes second. That gives you 2 different arrangements for the symbols. Are you okay? So there are 7 ways where the symbols put together could be put. When we take the symbols out, the rest of the 6 could also be arranged in 6 factorials. Then the symbol itself could also take 2 different ways. So guys, this is the number of arrangements that would be possible if the 2 symbols have to be kept together. So we do that calculation. And that, I guess, should give you 10,080. So if we are to create a code such that these 2 symbols of the dollar and the dollar sign and the asterisk could be kept together, all right, we would have 10,080 codes. So that is it for the III part for the permutation of question 5 in QP 1-2. May-June 2015, question 5, QP 1-2. B. 2 teams, each of 4 students, are to be selected from a class of 8 boys and 6 girls. Find the number of different ways the 2 teams may be selected. If I, there are no restrictions. II, 1 team is to contain boys only, and the other team is to contain girls only. The B part of the problem, still on question 5. The B part is a combination problem. Now, the question that was read to you in the combination says that 2 teams, each of 4 students, are to be selected from a class of 8 boys and 6 girls. All right, so let's look at the B part. Very simple. We'll try and deal with that. So we have a class and we have 8 boys, okay, and 6 girls. So 8B, 6G. That means that 8 boys and 6 girls. And the problem is telling us that we want to form 2 teams, each of 4 students. So 2 teams. Team 1 should have 4 students. Team 2 should also have 4 students. Okay? And we are saying that we want to find a number of ways in which the 2 teams may be selected if there are no restrictions. If there are no restrictions. So we don't care how we do the selection. How is that possible? Now this is a combination. So if there are no restrictions and want to form 2 teams, 4 each, essentially, what does that mean? What it means is that out of the 8 boys and 6 girls, or the 14 people, we want to choose 8 persons. Hope you're okay. Because we are saying that the team should have 4 in each. So when you have 4 there, that gives you 8. And this 8 is going to come from a pool of 8 boys, 6 girls. So if there are no restrictions, you are not going to put in any conditions. Then let's just go put together the 8 boys and 6 girls. We have 14. Then out of the 14, we choose 8. Right? So that gives us 14 choose 8, 14 combination 8. And that will give you your answer for the I part without restrictions. Okay. Right. Now, let's see that. And I'm sure when you're able to compute that on your calculator, you should get 3,003. So we can have 3,003 different ways or different means that are possible for us to select that particular 8 people from the 14. Now, let's come to the II part. The II part is where we have a restriction there. It tells us that 1 team is to contain boys only, and the other team is to contain girls only. So now we have a condition. These 2 teams that we want to create, 1 team is to contain boys only, the other team should contain girls only. So what do? It's logical. If you want to have girls only, then go and take the girls and choose the girls from there. If you want to have boys only, go to the boys pool and select the boys from the boys pool. Is there any way we have to think about this? Very simple. So what happens? Go to the boys pool, 8, and choose boys. 8 choose 4. Okay? And go to the girls pool, 6, and choose girls. 4. That's it. So the number of ways in which we can make the selection, or we can build a team such that we can have an all-boys team and an all-girls team is to go to the boys, 8, and choose 4. And remember, means multiplication in permutation and combination. And go to the girls team, they are 6, and choose 4. So the answer to the II part is 8 choose 4 times 6 choose 4. And when you're able to do that, ladies and gents, you get 1,050 selections, which means that we can produce 1,050 teams if this is the arrangement that we want to have. So for 2015 May, QP 12-1-12, like QP 1-2, the question that came, question 5. The first part had to do with the permutation, which we've been able to resolve. Then the second part was had to do with the combination that we've been able to resolve. And I'm sure that if you did it correctly, you should have all your answers. Remember, I encourage you to go to our website at learnwestafrica.com and make sure that you look at the videos there and take up our revision course. You can also look at most of our videos on our YouTube channel there for you. So that is it for QP 1-2. Question 5, QP 21, 2015. A lock can be opened using only the number 4351. State whether this is a permutation or a combination of digits, giving a reason for your answer. B, there are 20 numbered balls in a bag. 2 of the balls are numbered 0, 6 are numbered 1, 5 are numbered 2, and 7 are numbered 3, as shown in the table below. 4 of these balls are chosen at random without replacement. Calculate the number of ways this can be done so that the 4 balls all have the same number. The 4 balls all have different numbers. The 4 balls have numbers that total 3. Okay, so let's look at the question 5, QP 21 of the 2015 problem in May. Question 5, QP 21. Now, the question as was just read onto you, says read on the screen or shown, and just look at the parts. It says that a lock can be opened using only the number 4, 3, 5, and 1. 4, 3, 5, and 1. A lock can be opened using only the number 4, 3, 5, and 1. Let's look at that. The A part says that you've got the number 4, 3, 5, and 1. And the lock can be opened using only this number. Now, the question is asking for the first part to state whether this is a permutation or a combination of digits, giving a reason for your answer. Can be used. A lock can be opened by using only the number 4351. Only the number. Now, emphasis. You can only use the number 4351. Let me ask you a question to help us to resolve this. So by this, what we are saying that this lock can be opened by using only the number 4351. If you wanted to open the lock and you didn't key 4351, but you probably put 5431, do you think the lock will open? Will the lock open? Obviously, the lock will not open because it says that you can only use the number 4351. So if you don't use 4351 and you go and use 5431 or any other number, obviously the lock will not open. What we are saying is that when the order, how the number should stream is of importance or determines the effect, we call that a permutation. Simple. So in permutation, the order is very important. How should the number be put? So you need 4351. That's what we are saying. So I can't go and mention anything else. It's like a phone number. Someone tells you, what is my phone number? Oh, my phone number is 4351. Okay, I choose to now dial 5431. Do you think the number will go to the same person? Obviously not. So when the order is important, we call that a permutation. So we are saying that this situation is a permutation and not a combination. Okay? So permutation or combination. The reason is that the order is important. That is the distinguishing feature about permutation. So that's the E part for the problem. Now the B part says that there are 20 numbered balls in a bag. 2 of the balls are numbered 0, 6 are numbered 1, 5 are numbered 2, and 7 are numbered 3, and there was a table that was shown. Now let's try and reconstruct a table that was given you, then we'll see. So guys, just look at it. So this is the, okay, so this is what we have, okay. So the numbers are 0, 1, 0, 1, 2, and 3. So we have got 0, 1, 2, and 3, okay. All right, so this is what we have here, like that. Okay, 0, 1, 2, and 3. 0, 1, 2, and 3. So this is the number of the ball, okay? And we've got the frequency. So the frequency actually tells you the number, like how many of those balls are found within there. And the problem tells us, or the frequency is given us in the question to be 2, 6, 5, and 7. Okay, let's just try and write that, 2, 6, 5, and 7. So we've got 2, 6, 5, and 7. 2, okay, so 2, 6, 5, and 7. Guys, hope you got that. All right, so now the problem is telling us that 4 of these balls, okay, are chosen at random without replacement. We want to calculate the number of ways this can be done so that the 4 balls all have the same number. 4 balls are going to be chosen at random. And we are saying that how many ways can this occur so that all the 4 balls would have the same number. All the 4 balls will have the same number. Guys and girls, how do you think we can go about this? All the 4 balls will have the same number. So how do you think we can go about it? We want to have 4 balls that are chosen and they have the same number. Now if you look at the table, the frequency tells you the number of balls that you have in the basket or the container. So the balls that is labeled 0, they are 2. The ones that is labeled 1 are 6. The one that's labeled 2 are 5. The one that's labeled 3 are 7. So, question. If we want to have 4 balls, for them to have the same number, what kind of number will those balls possibly have? What kind of number will those balls possibly have such that we can get 4 of them? Can it be 0? Obviously not, because the 0 is just 2. You only have 2 balls that have got the label 0. So for us to have 4 balls of the same number, it cannot be 0. So those balls will either be 1, 2, or 3. Hope you are fine. Good. So that is how we are going to go about it. Okay, so it could either be 1 or 2 or 3. So what happens? Therefore, the 4 balls that we are interested should be chosen from this set. Okay, so out of that, we could have 6 choose 4. 6 choose 4 means that out of the balls that are labeled 1, we could choose 4 or plus. Out of the 5, we could choose 4. Okay, so 5 choose 4 plus. Out of the 7 balls, we could choose 4. So 7 choose 4. Hope you're okay. So you can have 6 choose 4 plus 5 choose 4 plus 7 choose 4. Now, if we are to do that, we should have 35. Okay, so we can get 35 of the balls. 35 of the balls having the same number. These are the possibilities. Okay, either we choose from the 1, 2, or 3, and that's how you go about it. Hope you're okay. All right, the II part tells us that the 4 balls all have got different numbers. The 4 balls have all got different numbers. So how do you go about that? The 4 balls should all have different numbers. The 4 balls should all have different numbers. Okay, so let's see. Let's look at how we can do this particular arrangement. Now, permutation and combination is basically a very logical subject. So all the 4 balls should have different numbers. How can we have this done? You have different numbers. How can we have this done? Okay, so now we'll just try and see our construction and see what happens there. So we can have situations. Let's look at a situation. The balls with 0. Okay. And we can also have, okay, we can also have, like we are saying, the balls all should have different numbers. So what you have to just do is just break it down for us to see the number of possible arrangements that are there if you're going to have different numbers for the balls. Hope you're okay. All right. So now let's just look at that. All the 4 balls should have different numbers, which means that you cannot have more than, okay, 1 ball having the same number. That can happen. All the 4 balls should have different numbers. So what do we do? Any idea? You look at the distributions there. What happens? All the 4 balls should have different numbers. That's what the problem tells us that. Okay, the 4 balls all have different numbers. Okay, so if all the 4 balls have got different numbers, basically, then from the 0, we should be able to select 1. The ball with the label 0, we choose 1 from that. The one labeled 1, we choose 1. The one labeled 2, we choose 1. The one labeled 3, we choose 1. That's all. When we do that, we can have all our 4 balls with different numbers. Because the moment it doesn't come from any of those separate ones, then what it means is that one of the balls is going to have the same number as another one. But that's not the requirement of the problem. Okay, so we just go straight. So out of 2, we choose 1, which means out of the 0, we'll select 1. Okay, and 6, we choose 1. And 5, we choose 1. And 7, out of the 7 balls, we choose 1. Okay? So that's okay for us. All the 4 balls should have that. So we just do our calculation, and that should give us our number. All right? Okay, so we're going to have 2 times 6 times 5 times 30. That should be for us. So out of the 2 balls, we select 1 and, okay, the next one should come from there. 6 choose 1 and the next one come there. 5 choose 1 and 7 choose that. So 2 times 6 times 5 times 7 should give you your answer for that. Now let's look at the third part, the I part. Okay, it says that the 4 balls have numbers that total 3. The 4 balls have got numbers that should total 3. So how can we arrive at that? Okay, so the 4 balls should have numbers that total 3. How is that possible? Let's look at the frequency, and we'll see how we can do a selection to get the 4 balls having the total of 3. Okay, so how many ways can we arrive at 3? Okay, so we can select some of them from the ones with 1 and 2. That will give you 3, okay? And also that one. The total of the 4 balls will give you 3. So what can happen with that? All right, so this is the arrangements that we can have. Let's look at the arrangements, and we'll see how to go about it. So our 4 balls, if we want to have the total being 3, we cannot select a ball from here. We cannot select a ball from here. Why? Because this ball here has got a label being 3. So when you just select 1, okay? When you just select one of the balls, the label on it is 3. So once the label on it is 3, the next ball is going to give you a value that will add up for it to be more than 3. That wouldn't work that way, okay? That obviously would not work. So how do we go about it? How do we go about it? So what we can do is that the ball that is labeled 1 here, this one, right? We can select 3 out of it, okay? Then, what else? You can also select one of the balls here, okay? The 0. We can select 1 from there. Hope you are fine. Are we making sense? We want to select 4 balls so that the sum of them should give you 3. Okay, so what we are saying that here you have got 6 balls that have got 1. Those 6 balls, you can choose 3 of them. So that is going to give you that. Okay, then The one that is 0, you select 1. So you have 4 balls at the base. Remember, what we are writing down at the base is the number of balls that has to be selected. This is going to give you a total of 4 balls. And these 4 balls will have a total sum of 3. We are fine because 3 of them is selected from that. Okay. All right. That's fine. Okay. So what's the other arrangement that can be done? So this is possible. Then the other arrangement will be what? What will be the other arrangement? Okay, so the numbers that are 0 here. Okay. The one that is 0. We can select 1. We can choose to take that one and not choose anything at all. Okay. Okay. Then we take the 1 here and choose 4 out of it. Hope it makes sense. Are we making sense? What we are saying is that because we want the total sum on the balls to be 3, right? The total sum of the balls to be 3. You can have all the 4 balls coming from that. Okay. Then the other one would have 2, 1, 1. Hope you're okay. 2, 1, 1. What is 2, 1, 1? Which means that the one that has the number being 2, we can select some from there. And the one that has 1, we select 1. The other ones, we select 1. Hope you're okay. So when we're able to put that together, we can find the solutions there. So essentially, we are going to have 2 choose 2 times 6 choose 1. Okay? Times 5 choose 1. Then you're going to have 2 choose 1 times 6 choose 4. So we add that. Or you're going to have 6 choose 4. So when you put that together, you should get 85. That should be the result for that. So for your May 2015 QP question 2-1, that is what you get for the A part. We'll resolve.